Hi everybody, we're going to take a look at guided notes for standard 14, properties of quadrilaterals. And in today's notes, we're actually going to be doing a lot of investigating. We'll complete 4 different activities to learn about these special quadrilaterals. These are all quadrilaterals with the root word quad, meaning they all have 4 sides. We will define these first 2 terms and then we'll come back to the last 3 terms. So our first term to define is a trapezoid. And I have some figures of trapezoids here, and I see that I have arrows on here, 2 of my sides, or this pair of sides. And these arrows are showing that these 2 sides are parallel. So we can define a trapezoid as a quadrilateral because it does have 4 sides. So we'll say that it's a quadrilateral with 1 pair of parallel sides. Quadrilateral with 1 pair of parallel sides. The other term that we will define right now is a parallelogram. And when we look at these figures of a parallelogram, I now have 2 pairs of parallel sides. So I can see that my top and bottom side here are parallel. They have 1 arrow each. And then my left and right side are parallel. They have 2 arrows each. So a parallelogram is also a quadrilateral, but it has 2 pairs of parallel sides. So we'll say quadrilateral with 2 pairs of parallel sides. And we're going to come back to define rhombus, rectangle, and square after we take a look at these activities. So our first activity is looking at parallelograms, which we defined as a quadrilateral with 2 pairs of parallel sides. So you can see that on this figure of the parallelogram, we also have the parallel tick mark showing which sides are parallel to which other side. And this is an activity. So step 1 tells us to measure the angles and the sides of the figure. So you are going to need to get your protractor that you were given in geometry. And once you measure all of the angles and sides, you'll be able to answer which angles and sides seem to be congruent. In step 2, you will measure the diagonals. So here are our diagonals. I can give you a hint that you could put your intersection point here in the middle. And when you're measuring the diagonals, I would measure this part of the diagonal. Say we could label this point M. I could measure this part of the diagonal from point D to M, and then I could measure this part separately from point M to point B. So you're going to be measuring your diagonals and saying which parts of the diagonals appear to be congruent. And then the last question that you'll be answering, it says consecutive angles of a polygon are angles that have a side in common, meaning if we were to look at this bottom side, that means angles D and C are consecutive angles. Or we could say angles D and A are consecutive angles because they would share this side. What do you notice about the consecutive angles in a polygon? So you first need to make all of your measurements on your figure in order to answer these 3 questions, and then we will come back and we will do these conjectures together. So at this time, go ahead, pause the video and see what you come up with for these 3 questions. So here are the measurements that I came up with on my parallelogram. If you want to, you can pause the video if you want to double check how precise you were in measuring the different angles and sides. For which angles and sides seem to be congruent, I found that the opposite angles, so like here angles D and B were both 60 degrees and angles A and C were both 120 degrees. I also found that the opposite sides were congruent. So my top and bottom side here were 7 centimeters and my left and right side were 3.5 centimeters. Which parts of the diagonals appeared to be congruent? Well, I found that the diagonals are bisecting each other. And that's actually why I had to label this middle point M for midpoint, because this point is cutting or bisecting our 2 diagonals here in half. So from point D to M, I had 4.6 centimeters. And then same thing here from point M to B, it was 4.6 centimeters. So our diagonals are bisecting each other, meaning they are cutting each other right in half. What do you notice about the consecutive angles in a parallelogram? I noticed that they are supplementary, or they add to 180 degrees. So here, if I look at angles D and C, 60 plus 120 gives me 180 degrees. Here, if I look at angles D and A, because they are also consecutive angles, 60 plus 120 gives me 180 degrees. So now that we used our figure to come up with these observations, we can answer conjectures about the properties of parallelograms. So we can say that opposite sides of a parallelogram are congruent. Opposite angles of a parallelogram are also congruent. Diagonals of a parallelogram bisect each other. And lastly, consecutive angles of a parallelogram are supplementary, meaning they add to 180 degrees. So now if we flip to the back side, we have 3 more activities. So activity 2, we are now looking at rhombuses. And you're going to need to do the same thing. You're going to need to get your protractor. And in step 1, you're going to need to measure the angles and sides in order to answer this question. And then you're going to need to look at the conjectures that we just made about parallelograms. So you'll need to flip to the front side of your page to the conjectures that we made about parallelograms in order to answer if those conjectures also seem to be true for rhombuses. So at this time, go ahead, pause the video, and see what you come up with for these 2 questions. Here are the measurements I came up with for my rhombus. And I found that the opposite angles are congruent. So angles D and B were each 30 degrees, and angles A and C were each 150 degrees. And I found that all of my sides were congruent. So all 4 of my sides were 5.5 centimeters. Do the conjectures you made about parallelograms seem to be true for rhombuses? And I said yes, meaning if you considered the 4 conjectures that we made about parallelograms, we said that the opposite sides are congruent. Well, yes, that is true. The opposite angles are congruent. Yes, that is true. The diagonals bisect each other, and here I found by measuring my parts of the diagonal, or halves of the diagonal, they did bisect each other. And the consecutive angles are supplementary. So here, if I'm looking at angles D and C, 30 plus 150, yes, it adds to 180. So because all of those conjectures that we made about parallelograms are also true for rhombuses, right here we can say that a rhombus is a parallelogram. Rhombus is a parallelogram. And the other conjecture says that the diagonals of a rhombus are, and right here I measured each of these angles actually, and all 4 of these angles here where the diagonals meet are 90 degrees. So that's why I put a square tick mark. So if all 4 of these angles are 90 degrees, that is showing that our 2 diagonals are perpendicular. They are perpendicular. And right here, these 4 angles are each 90 degrees. All right, so now you're going to pause the video and see what you come up with for measurements and the 2 questions for activity 3 on rectangles. Here are the measurements that I came up with for my rectangle, and I found that all angles were congruent. So all 4 of my angles in the rectangle were actually 90 degrees, so that's why I put the square tick marks on them. The opposite sides were congruent, so my top and bottom sides were 6 centimeters each, and my left and right sides were 3 centimeters each. And just like with the rhombuses, I found that for the rectangles, all of those conjectures that we made about parallelograms are also true. So I said yes. This means that a rectangle is a parallelogram, meaning it has the 2 pairs of parallel sides, and all of the conjectures that we came up with for parallelograms are also true of rectangles. And I found that the diagonals of a rectangle, and this was actually something fascinating that happened, and I measured actually each part again, so as if here was our midpoint. Each part was actually 3.5 centimeters, or you could say that each diagonal was a total of 7 centimeters. So these two diagonals are actually congruent, which was a little bit different, right? We haven't found that yet where the diagonals end up being congruent. All right, you've got your last activity, so go ahead, pause the video and see what you come up with for activity 4, squares. You can check the measurements that you came up with here for your square. I found that all of my angles were congruent, so all 4 of my angles here were 90 degrees, so I added a square tick mark to each. All of my sides were congruent, so each side was 3.5 centimeters. And I found that all of the conjectures that we came up with for parallelograms were also true for squares. So that means that a square is a parallelogram. It is also a rectangle, because here we had our 4 right angles. It's also a rectangle. And it's also a rhombus, because here in our rhombus, we had all of the sides having the same measure. And so here, all of our sides have the same measure. So it's also a rhombus. Another key piece here with the rhombus was that our diagonals here were perpendicular, so that all of these inside angles were 90 degrees. That was also true with our rhombus, and then we noticed it with our square as well. And then for a rectangle, we can also point out that here our diagonals were congruent, and we found that with the rectangle, diagonals were congruent. The diagonals of a square, right here, we can break that down even more. The diagonals of a square bisect each other. They're bisecting each other right here at this point. They are perpendicular to each other. And they are congruent. Diagonals of a square bisect each other, are perpendicular, and are congruent. So we're done with all 4 of our activities, and the last thing that we need to do is jump back to the front page of our notes and finish filling in our last 3 definitions. So we need to define a rhombus, and a rhombus, we discovered that it is a parallelogram. So right here we defined a parallelogram, and in the activities we also came up with some different conjectures that must be true for a parallelogram. And a rhombus is also a parallelogram, so those conjectures have to be true. So we can define a rhombus as a parallelogram. And we found that a rhombus has 4 congruent sides. And the figures here show that because we have the 4 congruent tick marks. So we'll say a parallelogram with 4 congruent sides. Next, we have a rectangle, and a rectangle we said is also a parallelogram. Parallelogram, and the rectangle had 4 right angles, or 4 90-degree angles. So parallelogram with 4 right angles. And then lastly, a square is a parallelogram. And the square had the properties of both the rhombus and the rectangle. So we can say that it's a parallelogram with 4 congruent sides. So that would be like the rhombus, 4 congruent sides. And like the rectangle, 4 right angles. Parallelogram with 4 congruent sides and 4 right angles. So we have all of our definitions here, and a trapezoid is by itself because it only has 1 pair of parallel sides. But then the rest of the quadrilaterals that we defined here are all classified as parallelograms. But we can be more specific and say that a rhombus is a parallelogram with 4 congruent sides, a rectangle is a parallelogram with 4 right angles, and a square is actually a parallelogram, a rhombus, and a rectangle.